In the last lecture, we encountered a special notation as you like this, where we can put in ampersand and a variable name to denote the address of that particular variable, right. So, that is what we encountered in the earlier class. Next, we will be now we will be moving ahead towards some statements which are absolutely essential for writing any C program. Just as in English we write different types of sentences, similarly in the language C, just as it is a language, there are again different types of statements that we can write and through which we can express what we want to do. The simplest type of statement that we have already encountered about is assignment statement. Assignment statement means I have got some contents in some register say x, some memory location say variable x, and has got some value 50. Now, how does this value come over here? Initially it was not there. So, suppose I have got a memory location variable say speed, and I want to put in some value into this location, all right, say 500. So, what we do? We write speed assigned 500 semicolon. So, the general syntax for that is a variable name followed by the expression, okay? The variable name followed by the expression. As you have written here, speed is the variable name and the expression here is nothing but a constant, all right. It could be something else. For example, I could have written speed assigned 2 times 500, or maybe V times Q, whatever, speed is assigned V times Q. Here are some examples of such assignments. As you can see here, velocity is a variable, right. On the left hand side, the variable name is there. On this side is an expression. Now, what type of expression is this? 20 is nothing but a constant value. Please note that all the statements must be ended with a semicolon. Look at the second one, B assigned 15, again a constant. Look at the third one, temp assigned 12.5. So, what type of variable is temp? You will immediately answer temp must be a floating point variable or real number. Here you see a different type of expression. A variable A is being assigned the variable A plus 10. What does it mean? So, A assigned A plus 10. So, A being a variable, A is a memory location, and suppose it has got some value 25.7. if A is a floating point variable. Now, if I do A assigned A plus 10, that means whatever is there in as the value of the variable A is taken out. So, we take out, we read 25.7, add 10 with that, and we get 35.7, and then this 35.7 comes in here and I get a new look of A, the same location will now hold 35.7. So, you see the left hand side is the destination where the new value after computation of the expression will go, and the the right side can have the same variable as the source, or might be the some other variable, could be some other variable also, like here this expression you see. I am using 3 variables here. V is one variable, U is one variable, I am sorry, I am using 4 variables here. F is another variable and T is another variable. Now, suppose U has got some value 20, F has got some value 0.5 and T has got some value 2. Then V is being computed as U is being taken 20 plus the product of these two, 2 and 5. So, 2 and 0.5 will be 1 and 1 is being added to 20. So, these two being added is becoming 21 and this 21 is filling up this variable V, all right. So, here you can see I can use more number of variables. I am sorry, this is, let us be a little nice. So, it should be 21.0. Similarly, here you see it is a mix of variables. How many variables are here? S is a variable, U is a variable, T is a variable, F, T, T, F, T. So, 1, 2, 3 variables are there. Again U, F, T and S, all right, and there is a constant 0.5. So, this side, entirely this side is the expression. Similarly, this is again an expression, this is an expression, this is also an expression. We will see more of these expressions in a moment, all right. So, a value can be assigned to a variable when the variable is declared. For example, when I am declaring a variable, just starting, I want to declare a particular variable and so I want to declare a variable maybe acceleration, all right. Now, when I say that acceleration is a real number. So, when I declare it, I will write float acceleration and then at some point later on I can say acceleration assigned say 2.5. This is one way. The other way is that I could have written it when I declared it as float acceleration assigned or initialized to 2.5. This is also allowed in C. Okay. So, a value can be assigned when it is declared. For example, here speed is an integer which is being declared as an integer and along with that it is being assigned the value 30. Here you see the char is a type of another variable flag, and when I am saying that it is a flag is a character, I am along with that I am also assigning it to value y. Now, you understand, you remember that within the single quote means it is the integer, it is a character string. So, I could have done it also like this, char flag and then later on flag assigned y, and this is equivalent to what I did here. Okay. Several values can be assigned the same value using multiple assignment operators. What does it mean? As soon as we see the example, it will be clear. For example, A, B, C, all these are being assigned the value 5. Flag 1 and flag 2 both are being assigned the value y. Speed and flow both are being assigned the value 0.0. So, here say for example, the correct thing would be to say float, speed, flow assigned 0.0. Okay. So, that is the simplest possible way we go about it. Now, when we write an expression, first thing we have seen now is the assignment statement. Now, in the assignment statement, if you have seen in the earlier slide, we were using some operators. For example, U assigned say V minus F times T, all right. So, this is an assignment statement. Here is the assignment. Okay. But on this side, I have written an expression. So, how can we write an expression in C? We have seen quite a few examples of such expressions in the earlier slides, right. We have seen different types of expressions like S assigned U times T plus 0.5 times F times T times T. So, it is, we will immediately recall that this is our standard school formula, S is equal to U T plus half F T square, right. Now, this expression has got two components. This well known expression in school has got two components. One side is the expression here, which has to be computed, and then that has to be assigned to another result or another variable. So, that is being written here. Now, this is the way an expression is written in C. You cannot just write it in this way as we are doing in our school. This is not possible. We have to write it in this way. Okay. Now, here when we write this expression, you please observe a couple of things. Look at these, this. These are known as the operators. You know that this is meaning multiplication, this is meaning addition, these are again multiplication symbols. Now, there are sets of allowed operators in C, just as every language allows some constructs to form sentence and some other constructs are not valid in a sentence formation. Similar to that, in the programming language C, or for that matter for any programming language, there are some allowed operators by which we can form expressions. Okay. So, we have got three types of operators. The type of operators that we have encountered till now, we have seen till now, are arithmetic operators. But besides arithmetic operators, there are two other types of operators called relational operators and logical operators. Okay. So, let us see a little more of this. Arithmetic operators, these are some of the very familiar arithmetic operators, right. You know that this means addition, normal subtraction, this is division. Remember, unlike this sort of division that we use in school, we use here this symbol for division. Unlike this symbol that we use for multiplication, here we use this symbol. And new symbol that we are introducing here is this symbol, like the percentage sign. Now, this does not mean percent, computing percentage, it means modulus. What does modulus mean? Say, if the modulus means finding the remainder. For example, if I compute 15 modulus 3, that means I am dividing 15 by 3, and whatever is the remainder is my result. So, what is my remainder here? Remainder is 0. Okay? So, modulus is basically the remainder operator. So, another example let us look at, say I have got 27 modulus 2. What would the result be? 27 divided by 2, the quotient is 13, right? Quotient is 13 and the remainder is 1. So, this modulus will be 1. Whereas, if I had done 26 modulus 2, that would be 0. Now, again observe, if I instead of modulus operator, if I had done 26 divided by 2, the result would be 13. So, this gives you the quotient, whereas this gives you the remainder. All right. So, this is a new operator that we are coming across and you should keep that in mind. Next, let us proceed. Now, here are some examples. Distance is rate or velocity or speed multiplied by time. Please note again, as I have told earlier also, that any expression must end with a semicolon, as is being done here. What does this mean? Can you read this variable? Can you read this variable? Is it meaningful? Net income is income minus tax. So, operator is minus, and this is the arithmetic expression, and this is the arithmetic operator. Speed is distance divided by time, again ended with a semicolon. Speed is distance divided by time. How do we find the area of a circle? Pi, you remember pi, we can define pi, we had seen this example earlier, has defined pi 3.1415 etc., etc. We could have done that. So, pi is a constant times radius times radius. Here basically what I am computing is area is being assigned, here is the assignment operator and the expression is pi r square. Now, this expression I am writing in this way, pi times r radius times radius. Okay. Here is another expression, y assigned a x square. What does it, how do we write it typically in school? This is expression which is a x square plus b x plus c. All right. This is a very familiar expression of a quadratic expression. Now, when we write it, again here you see how many operators I have. I have got 2 multiplication operations, 3 multiplication operations and 2 addition operations, right, and 1 assignment operation. So, here again quotient is dividend divided by divisor. Now, this is exactly what I was telling a couple of moments back, that this operator is actually returning you the quotient, all right, of a division operation, and this is actually giving you the remainder of a division operation. So, here are some examples of arithmetic expressions. Suppose x and y are 2 integer variables and whose values are, we know, 13 and 15. Then x added to y, x plus y, arithmetic operator plus will give me 18. X minus y, 13 minus 5 will give me 8. Now, the point to note here is that here again always try to think in terms of our memory location diagram. X and y are two variables, x is 13 and y is 5. So, x plus y means the content of the location x plus the content of the location y. X minus y is the content of the location x minus the content of the location y. Similarly, when we multiply, it is 65. Now, if I add an assignment with this operation, I just add an assignment. For example, I am giving two variations, z assigned x times y. That means what? There is another location z where the content of x and the content of y are taken and multiplied, and 13 times 5 is 65, that is stored there, and that is possible because I have assigned it here. Again, I could have, as an alternative, could have done x assigned x times y. What would have happened in this case? The content of x would have been taken 13 multiplied with the content of y, that is 5, 13 and 5 would be 65, and this product 65, where would that be written? It would be written in x. Why? Because it is being assigned to x. So, then this would be overwritten with 65. Okay. Similarly, you will recall now x divided by 2, this is a division. So, I am expecting the quotient 13 divided by 5, what will be the quotient? 2, but x modulus y would be the remainder of when I divide 13 by 5. So, that modulus is 3. Okay. Now, in an expression we can have different operators. If more than one different operator occurs in a particular expression, how will that expression be evaluated? So, now we are concerned about how we will evaluate or find the result of computing an expression. Okay. Now, here is a list in decreasing order of priority. So, if I have something like this, say x assigned p plus q times z minus x divided by L plus m. Now, here you can see that I have got different operators. What are those? Our well known operators are plus, multiplication, minus, division, plus again. Here is another operator, that is parenthesis. Now, as we learnt in school algebra that the parenthesis has got the highest priority, all right. So, I will first compute the elements which are within the parenthesis. So, first p plus q will be computed, then L plus m will be computed. Now, out of this p plus q and L plus m, which one will be computed first? Whenever these two, these are of the same priority, these parentheses. Now, if there be more than one operator of the same priority, they will be computed left to right. So, first we will have p plus q computed, all right. Suppose that is something, say let us call it a, some value a times z minus x, suppose this is computed to be some constant b. So, in that way it will be computed. So, the parenthesis has got the highest priority. Next, after parenthesis, it is unary minus. Unary minus means usually when we write something like x minus y, then I have got two variables on which I am carrying out this subtraction. This is a binary operator in the sense that I am needing two variables or two constants, two elements on which I am carrying out this computation. Unary minus means that particular variable is being operated on. For example, if I had something like this minus x plus 7.5 semicolon, and suppose x was 2.5. So, what will be the value? X is 2.5. So, first this will be done. So, it will be minus 2.5 plus 7.5. So, the result will be then 5. It is not that I will first compute this 2.5 plus 7.5 and then do the negation, all right. So, the unary minus, so here I had shown a variable, it could be something constant also, minus 2 plus 6. That means, you all know that 6 subtracted by 2, although it is plus, so because this has got the higher precedence. Okay. The next one is multiplication, division and modulus. These three will have the same priority: multiplication, division and modulus. These three operators will have same priority. Therefore, if I have an expression like say x division y multiplied by z modulus q, how will that be? Which one will be done first? This and this have got the same priority. Therefore, we will be carrying it out left to right, all right. But if the expression was something like this, minus x divided by y multiplied by z modulus q, then which one would be done first? First, this unary minus should be done first, followed by these three candidates, which will be done left to right, left to right. Okay. Next comes addition and subtraction. So, if I have got an expression again like say x times y, even before that let me put it p plus x times y divided by z minus q, then in which order would it be computed? First, plus will not be computed, multiplication has gotten higher priority, this also has gotten higher priority. So, out of these two, which one will be done first? Left to right. So, first I will do this, suppose this is yielding a result a. So, it will be p plus a, then divided by z minus q, and then this one will be done because left to right of the same precedence, suppose it is b, then it turns out to be p, it turns out to be p plus b minus q, all right. Now, out of this plus and minus have got the same priority, then which one will be done first? This part will be done first, suppose that is c minus q. This is how this entire operation will be done. For operators of the same priority, the evaluation is from left to right. Okay. In the next class, we will see some more examples of this and we will proceed further.